So let me start. So this is the picture of what we have seen earlier. So today's everything is about pods. So I thought let me just reuse the same picture what we have used earlier, just to recap on what is a pod. So pod is the basic building block of Kubernetes. It has a container. It might have volume. Typically, one pod, one container. But sometimes you might have more than one container in a single pod. But all the containers in the same pod do share the same single IP address and the port namespace. So this is slightly different than Docker. In the Docker, every container gets its own IP and can have its own port numbers. So we will demonstrate that a little bit today. Okay, so what we are trying to do today is going to be pod, replication set, deployment, label selector. I kind of covered last time, so I'll not do that. We'll look into health check or self-healing, and jobs and cron jobs. This is the agenda for more or less today. Okay, so let's start with a very first example here. So I'll move to my environment. But let's see this particular YAML file, which is to create a pod. So this YAML file basically is a multi-container pod. I want to, so far what you have done last time is we created a pod with a single container. So this time I thought it would be interesting to have an environment with multiple containers in a single pod. So I have two images here. It's a very, very simple specification. API version is v1, kind is pod, metadata is just having name and label, and container specs are two containers, two different images. One is hello node, other is bootcamp, what we have seen last time. First container is on the port 8080, another container is on the port 8081. So these are the two containers what I have here. So let me switch and go to my terminal here. So let's see. Okay, guys, is it visible? Okay, sounds good. Okay, so what I have here is a multi-container. Okay, so I'm just getting that file once more, what I showed you just now. So this is the file what we have. So the command to really create the code is very simple. kubectl apply -f, the name of YAML file here. So I have multi-container.yaml. So I'm applying this. So let's see, before I'm applying this, let's see what I'm expecting here. So what I'm expecting is the system will create a single pod, and that pod will have two containers. And for each of the container, it will pull the image, because I have run this command earlier. So both images are locally available on the same Minikube environment. So image pulling won't take much time. So it will instantiate both the containers, and then basically we can look into the status of the pod, and we can look into the logs of both the containers is what we'll try to do. So let me apply this. So it's practically get created immediately. And now I can do kubectl get pods. You'll see this pod 2/2 is basically this pod has two containers. And 2 means both of them are up and running. And status is the status of the pod. So guys, there is difference between status of the pod and status of the container. See, as long as pod is up and running, the status will be running. And if one of the containers is not ready, then the ready status count of 2, that might be less than 2. If only one container is running, then it will say 1/2. If both the containers are not running, then it will say 0/2. But as far as pod is considered, pod will be still saying kind of running. And if you look into minus O void, then you will get other attributes like IP address of the pod, and on what node we are really running this particular pod right now. So what I typically like to do is let's look into the more details about this pod. So let's do kubectl describe pod and my pod multi, and let's see what all information we see here. So this is typically very first thing I want to do. So if you want to start really debugging anything with your Kubernetes object, then the very first thing you want to do is let's look into the current state of that object. See, spec is what we have mentioned in the YAML file, but then it is important to figure out the spec. So Surojit, let's hold on that question. We'll come back to that at the later point once I have the readiness probe, because most of the folks may not be available, may not be even knowing what is the readiness probe. So we'll look into that. Today I'm going to cover the probes, so we'll look into that time. Okay. So let's look into the spec, basically the current state of this particular pod. So here basically I have namespace, this node, and then label is what I have specified. Annotation is what system has given on its own. Okay, namespace is default here. Status is running. IP address is the IP address of the pod here. Now, interesting thing is the container. So in container, basically, we have opened the port of the container. So this is the kind of port. Then container ID, image ID, these are the information what you have. And then basically, these are something will be interesting. You are going to be seeing in different environment based on how things are really happening on your specific environment for your container. If it is restart count will be non-zero for some reason. If a container fails and then the Kubernetes pod restart the container, that time the restart count will be non-zero. So this is something for you to come and look at to see if did something go wrong in your container. Other thing to notice is the port number. Sometimes there's a port conflict. So if you happen to see two containers trying to work on the same port, then you know that's basically one of the containers will certainly fail. And then you want to look into the events. So let's look into the first event is the event which says, did Kubernetes scheduler find enough resources to even schedule the pod? So this is the message which says that my multi-pod, my pod multi was scheduled successfully to Minikube. So kubectl, basically kube controller did find enough resources in the Minikube to schedule my pod there. And then it is creating container. So it created the first container. So this command, this particular operation can take a lot of time depending on if the image is not present locally and the size of image. And then basically, once the image has been pulled, then it's going to create the container, going to start the container. So this is these are the things where you most likely want to see if you see the container restart, basically crash, loop back off, and things like that. Then first thing to look into this part. So in this case, both the containers were available. They were not conflicting, so everything just went fine. Okay, so now I can look into saying like kubectl logs my pod, this one. So hello node doesn't have any message being printed from there. And then I have bootcamp. So bootcamp is basically printing this message comes from the log there. Okay. So that's how I can figure out what's happening where. And if you want to really want to log into a container, then you can do kubectl exec minus it mypod minus c, let's say bootcamp bash. So here basically I can, so this is basically now I'm inside the container. So I can check what's happening here and things like that. Okay, so these are some basic set of commands by which you can validate what's happening in your environment. So I have here one more multi-container pod, but here what I have done this time is this specification I have two containers, but both of them are on the same port 8080, which is a failure scenario. So let's see what happens and what typically you might be seeing in this kind of scenario. So let me just first kill the earlier containers. So okay, so kubectl apply minus f multi-container same pod.yaml. Okay, so now if I say kubectl get pods, you begin to see that crash loop back off is the problem what you are seeing. So how do you debug that? So typically what I will doing, describe pod so I see basically something is really going wrong with my bootcamp container. All if I were paying attention, then I can really see that two containers are showing sharing the same port. So I can see that this is on 8080, this is also on 8080. But if I happen to miss that, but I'll certainly get to see that my second container is having problem. So I will try to figure out whether something is coming in the log for the second container. So I'll say, and then bootcamp. So if I were to do that, then I'll certainly see that I'm seeing a backtrace here, and that backtrace clearly says that my node code is able. This listen call is basically failing, saying address in use. So then I think it become very clear that second port has this particular problem, and then I can come and fix the problem, and I can continue from there. So these are basically simple ways for somebody to start looking into their container and pod environment and trying to figure out what is happening where. Any questions so far, guys? Okay, so let me continue with my slides in that case. So these are something what we have done. So basically in the pod, you might, so what we have done now is we have looked into containers part of the pod, but there are more attributes in the container. One is what we are not covering for today. I might cover that thing in the most likely sixth session is the storage. Uh, just give me a sec, guys. Okay, can you hear me? Okay, thanks. So basically, I was saying that we have looked into containers aspect of the pod. Something called storage or volume associated with the pod is something we are going to look after, not in today's session, but at some point in time. And events is something what we again looked into today. Node selector, I'm not going to be covering for now, but I think you can easily go and check what is node selector. Node selector is an attribute by which you can say that please schedule this particular pod. Let's say if you had a requirement to really have SSDs kind of storage, so you might really put a node selector saying that please schedule this pod only on the node which has an attribute of SSD. So that is a notion of node selector, but again not very common, so we'll most likely skip that for now. Okay. So now let's look into so today's session. Primarily, I'm going to be focusing on these different type of pod controllers. So as what we were discussing so far, pod is the basic building block of the Kubernetes. So what I really mean by that is in Kubernetes, containers are kept in the pod, but you don't do everything in the pod either. So Kubernetes has this very interesting object model where for everything there is a one object, but with each object there are only certain type of things what you do with a single object. You don't try to really do too many things with the same object, and then that object becomes unmanageable. Versus Kubernetes went with this design principle that for everything there is an object, but an object is relatively simple entity. So for example, if you want to really create multiple pods, then you don't really say that I'm going to add an attribute of replicas within the pod. There is a separate object called replica set. So replica set has a notion of replicas. So that is basically replica set. Now then there is something called deployment. So deployment basically is something built above or on top of replica set. So if I want to really create do a deployment, then I'll use deployment object, which in turn will use replica set for multiple copies of the same pod. But then it will have some other attribute saying that if I want to roll back, roll forward, so those becomes the attribute of deployment object. So and so forth. So look into these 5-6 things today. I'm not going to spend a lot of time on the stateful set and daemon set. Then we are going to look into job and cron job. So I'll spend time on these 3-4 things: replica set, deployment, job, cron job. We are going to just introduce what is the concept of a stateful set and daemon sets. So that is the kind of plan for today. Okay, so what I'll do is I'll go back to my terminal, and let's start playing with some of these things hands-on. So let me just delete earlier pod also, so that we have less clutter around here. Okay, so let me introduce the very first concept here of the replica set. So replica set, I have some very basic YAML file. So replica set is again built on top of just the pod. So as I mentioned earlier, this is the typical structure of a YAML file. So kind of the object here is replica set. Metadata is just the name of the object, and all I have here is the template. Is essentially what you typically see as a spec of a pod, which is typically if you are using some template, then you don't really put the name there. You just put the what kind of label you have, what container you have, and then here you have selector. This has to match with whatever label you have given for the label of your content pod here. That is very important. So these two things has to match, and most important thing is you define number of replicas here. Okay, so I have this replica set defined here. So I'll just do kubectl apply minus f and rs dot YAML. So this set has been created. So now I can do get rs ic bootcamp, where my desired state is 3 replicas. All of those are already there and all of them are ready. My age is just the 6 seconds old. Now if I were to do, please explain in the imperative method also replication in controller. See, in the imperative method, you don't have imperative method to create each and every type of object, Dina. So for certain basic things, they have given the imperative method, like you can create deployment directly from that, but not everything what you can do in the imperative method. Is match label mandatory if we remove it and just keep a label what exactly will happen as a default behavior during the installation of replica set? I think I have not really tried that, but I assume in that case replica set may not be able to really build something, but I don't know. I have not tried that, Surojit. That's an interesting thing to experiment. I'll not try it right now, but I think it will be something to try. And why don't you try and we can really look into that thing, what happens. My expectation is in that case, replica set object will get created, but it will not be able to map anything because we have not really specified any selector there. So it will say I have not really, I don't have a matching pod to really match and create replicas on. So that most likely should happen, but I'm not too sure. Okay, so let me just do get pods. So my all the 3 pods are up and running, and now let's look into the describe rs and bootcamp. So bootcamp is the name of my the replica set. So let's see what I see. So this object is very simple object as is expected. All it has is a selector and basically pod status and number of replicas, nothing else. Okay, so this is just to really let everybody understand that very simple iteratively building objects as a design principle is something what I really like about Kubernetes, where things don't go out of hand. It's a clean design, clean way of really architecting. So something what we potentially can learn and apply in our day-to-day activity also. Okay, so let's look into, so now I'll go to, I'll delete this replica set and then I'll go to deployment. RS bootcamp. Okay, when I delete it, then basically my pods are now beginning to get terminated and it takes some time before the pod termination completes. Okay, so it will happen automatically because to the Kubernetes, we already told to Kubernetes manifest or to etcd that I'm not interested in this particular replica set anymore. So that is the reason it's terminating. But instead of terminating the replica set, if you would have killed a pod, then the Kubernetes itself would have discovered that one of the pod has failed, and it would have recreated the pod again on its own, a part of his failure handling. Versus we deleting replica set means that we are telling Kubernetes that we are not interested in the replica set anymore. Okay, so having said that, let's go to the deployment experiment. So what I have done in the deployment is basically I have a YAML file and I wanted to demonstrate that in a single YAML file you can have a specification for multiple objects what you can create using the single YAML file. So practically what happens if you look into any interesting project Kubernetes deployment or YAML files, you are going to be seeing reasonably large YAML files. Is there a method when a deployment of a pod is getting instantiated and it is pulling image from a Docker registry? Can we see that somewhere in the log? Yeah, so if you look, Surojit, if you look into your deployment object and just go to the describe, so then you'll see the events which are happening on that pod. And one of those events are going to be saying that right now this fellow is pulling the image, but what you don't really get is there is no percentage progress per se. All it's saying that it is trying to get the image, but you don't really get to see how much of the image has been pulled so far. So that is one of the challenge I've seen, and I've seen multiple people commenting on that too. But I don't think that Kubernetes has given any facility right now for you to say that how much of the image has been received here. But events will keep updating every few seconds, so you'll be seeing that progress is being made, but it is in the state where it is pulling image right now. So I will show that once we create this deployment, we can get into the describe, or we can get into the events of this deployment object, and then there you can see in what state the things are. Okay, so I'll take this file. I'll just apply the YAML file here. What I should have done along with this here is kubectl get pods minus o white minus w. So w is basically a watcher, guys. So given that my images were available here, so it got created very quickly. Otherwise, it will take a lot of time. And here, one thing to notice is for each of the pod, we get the different IP address here. So what I'll do is kubectl get pods. I'll pick a pod and I will kill that pod and then see what happens. What does Kubernetes do in that kind of scenario? So I'll say kubectl delete pod. I don't know. So I'll just pick something from deployment object, not the deployment to. So this I'm killing, and then let's see what happens on this part. So basically the pod, what I was killing was having IP address 0.8. So it got terminating event. And while this fellow is still getting terminated, Kubernetes discovered that this fellow is terminating. So without even waiting for the termination to get completed, it has already provisioned a new container. And this container became up and running. And I got a different IP address here. And after a few seconds, the termination of the old container is still going on. It will take some more time before the termination completes. So this basically demonstrates that because you have this deployment object which has a replica count mentioned as 3, if one of the pod dies, although we have killed it synthetically here in real world environment, it might die because of the node dying. So Kubernetes will detect that and it will bring that a particular pod automatically immediately, is what I'm trying to demonstrate here. Okay, so now let's look into the other object. What we have created here is basically deployment. So let's do the get deployment. So I'm seeing 2 objects. I'll look into the first object here. And what I'll do is kubectl describe deployment type of the object, and this is my object what I'm trying to describe here. Okay. So here basically I'm having the name of deployment here, and then there are a bunch of things here, and here I had selector was so and so. Now let's look into something interesting here, guys. So here I'm mentioning number of replicas, what I was expecting here. Okay, and so these 2 lines, let's forget about the line which is saying min ready seconds. Let's skip that for now. So on this deployment, the strategy is given, which is by default is rolling update. So this deployment object supports the rolling update, and rolling update strategy is 25% max unavailable, 25% max surge. So these are configurable parameters. You can change these parameters in the rolling update strategy in your YAML file. You can mention max unavailable, max surge parameters, and you can change those parameters. So these parameters basically means that when I'm doing the rolling update of this particular deployment environment, see, for example, I created an environment with, let's say, 10 replicas. And right now I'm at the image version 1.0. Now I want to move to the version next image of version 1.1. So there are two ways you can really do that. One is you might say that I want to have a rolling update available. That means I don't want to stop all my pods of version 1.0 and shut it down, and then only bring up the version 1.1 and bring it up, because that will cause some kind of a downtime for some time. Versus what you are saying is, keep those 10 replicas there. Let me create two more replicas of version 1.1. And once I have two extra replicas there, I'll begin to kill only two replicas of version 1.0 to, so that I can stay in this 20-25% of my max unavailable as well as the max search kind of limits. So that way I will be slowly keep adding more replicas of version 1.1, and I will decommission the replicas of version 1.0, and over some time I will move everything to version 1.1. So how much should be unavailable of the old image and how much should be maximum extra pod I am allowed to create is controlled by these two parameters. Okay. So I will show you basically how does the whole thing really works in Kubernetes. So basically, if you see currently, oops. So my current image is basically Anurag Docker Bootcamp 1.0. And my intention is to demonstrate that how can I really change this image from 1.0 to 1.1 image. So what I will be doing is I'm going to be firing this command. This one, set image is the kind of my command what I'm going to really fire here. So goal is for me to go and change this image. So I say that kubectl set image for this deployment object, and for this is a container. So if I have multiple containers, then I might want to really update the only specific container. It's not that I need to update all the images at the same time. So I'm saying for so and so image, I want to update the container image, and hyphen record essentially what I'm telling deployment object is, please record this information on its own rollout history. So we'll see that in a minute. So before I fire this thing here on my other window here, I still have my get pod with minus watch enable. So I'll keep it this way. I'll come back to this window here, and now I'm firing this command here. Okay, and now see what happens on the watcher here. So you are seeing that it begin to create the new containers, and it is beginning to terminate some of the old containers, because my deployment object had 3 containers, but at no point in time it created 6 containers. It just created 1 container of the new image, and it was terminating 1 old container. So that's how it did its things. And if I were to now come here and just do the kubectl get pods minus o wide, so I'm seeing that this new containers up and running, and the old containers are in the terminating state. So at no point in time I really had no containers running. I always had 2 containers are always running. It might be either of the old image or new image, but that's how Kubernetes has really maintained the availability of the system. At the same time, it seamlessly really allowed me to change the image. So this is basically your rolling update strategy to change the images. Now Kubernetes will also remember the rollout history. So command for that is just go back and basically ask what Kubernetes to give you history of the rollout. So command is called rollout history and then the name of the deployment object. So this is basically number. Basically, if initially there was nothing there, and then I went and I did change this image to so and so. Now, if I want to undo this particular change because there was some error there, and if I want to just undo, then all I need to do is I'll just say this kubectl rollout undo. That's all I will require to undo. So last particular change, sorry. So undo is just going to take the last specific activity what you have done in the rollout, and it will just undo that. And if you were to go and really see that, it is going through the same process. So from its point of view, when you are doing undo, all you are saying is, now I want to go and change my image again. And most interesting thing what you will be seeing is in the rollout history, it basically created one more entry there. So you went from revision 1 to 2, 2 to 3, 3 went back to the same image. Okay. And if I really want to go back to specific revision in my rollout history, then I can again really say that. So there is one specific command by which I can really say go to rollout back to that specific revision is basically I can really do that too. So these are the basically kind of commands what you can really use where Kubernetes itself is keeping track of all your rollout histories, and it gives you enough control for you to really manage your CI/CD in some sense, where it will remember which image was rolled out when, and you will have the whole history to roll back to any of the image what you want. Okay. So guys, any questions on the rolling upgrade of the images with deployment object? See, Surajit, you will change the image of the container when you get a new build, and now you want to deploy that build in the production. So with each of the new build, you get basically a new image of the container. So right now, let's say you are running with the build version 2030, and you are doing weekly, you have weekly releases. So next week you are going to get 2031 will become your new release of your code, and with that release you are going to get the new image for the container. And now it is your job of really saying that how do I really go and really upgrade my software from the version 2030 to 2031 without really causing a complete downtime, is basically what we are talking about here. Does that make sense? Okay, sounds good. So what I'll do next is, so this is a very interesting concept, and so far at least I found it very, very interesting that an orchestrator software has taken the pain of really implementing a good use case of rolling upgrade. Seems to be relatively simple, trivial, just by integrating your CD part with Kubernetes. You can really get an integrated CD, basically continuous deployment can be really achieved through the rollout things, and it will always maintain all these details will be always maintained in the etcd. So rollout history you can always see which version got happened what day and things like that. Okay, so now let's do something very, very simple and trivial again. Now if I want to scale, so the deployment object basically gives two main things. One is the rollout, and second is scaling. So rollout is something what we have looked into, and scaling is again very, very trivial operation, at least from consumption point of view, although it's non-trivial for Kubernetes to implement that. Okay, so what I've done here is basically I will fire this command too quickly. So I said that please scale the bootcamp deployment object. Initially it had only 3 replicas. Now I said replicas equal to 5. And now let's see what happened here. So what happened here was basically it created these 2 replicas. And given that the image was locally available, it took just few seconds to really create these 2 replicas. And now if I want to really scale it down, then all I need to do is the same command. Now replica count can be, let's say, I now want to have only 1 replica. So I can just fire it saying that, okay, replica is equal to 1. And then basically you will be seeing it is terminating 4 copies of the pod. And if your load increases, then you might come back and really say, no, I want to now have even like 6 replicas. So 1 was already there, so it just created 5 more replicas. Yeah, so rollout undo will go back to only 1 revision, but if you really wanted to undo to a specific revision in your revision history, then there is a command which is I think rollout undo, and then you can say hyphen hyphen revision equal to specific revision number in the rollout history. So then basically just by a single command, let's say you had 4 changes done, and now you realize not just the last image is bad, last 3 images are bad. Then you don't need to just go one step at a time. You can just say, please take me back to the revision history number where revision history was number 3. So you can directly go to that point, which will basically still create a new entry in the rollout history and saying now revision command revision number is 11, but I'm back to so and so image, which was the image what you used in the revision history 3. So there is an option there in the rollout undo uh, command is basically can take a specific revision number also. Okay, any other question, guys, on the deployment object? That's correct. So you can look into the revision history and then you can go back accordingly. So that is the reason it becomes important when you are firing commands like set images to always use the option of hyphen hyphen record, so that just that whole command what you have fired there get recorded in the rollout history. If you don't have hyphen hyphen record, then all the history will be maintained, but then you need to look into each of the revision and then do the describe of those revision history to get more details about that. Okay, guys, so that's basically what I had on the deployment object. So the deployment object probably is one of the most heavily used object in the Kubernetes pod controllers. Replica set is more of an internal object what you'll use, but deployment once you get comfortable probably becomes your friend, and you'll use it for usual case of scaling up and down, as well as basically rolling upgrade. So these are 2 very common use cases of Kubernetes, and object what you'll be using that is deployment. You'll rarely use the pod directly. Okay, so sounds good. So let me try to get back to my slides to see what next do I have here. Okay, so these 2 concepts I'll just explain. They probably are slightly more advanced concepts. So until unless we have better understanding of few more concepts, it won't be. I can't justify creating YAML file for them and running those things here. So that's why I did not do that. So first type of object here is called like a stateful set. So if you recall in the deployment object, when I was killing a pod, A new pod was getting instantiated immediately, but that new pod happens to have different IP address. Uh, so basically, by default, the Kubernetes pods are stateless, or you can say ephemeral. If some pod goes down, then you can just create a new one without worrying about the identity of the old pod. So it works in a lot of use cases, but it doesn't really cover the use case of you really requiring the same consistent image, including your IP address or identity of the pod. If you can't afford to change that for some reason, for example, if you have a specific database servers which requires the same IP address to come back, then basically what you will need is an stateful set where the IP address and storage, they remain same across the port failures. So that's the notion of a stateful set. It essentially have something very similar to the deployment YAML file, but the type of object is stateful. Other attributes are very similar to deployment object there. Only difference there is the whenever any failure happens, then Kubernetes will wait to serialize the old pod really dying, and then it will create the new pod with the same IP address and identity. So that's how the stateful object is different from deployment, but otherwise conceptually it is very similar. Second concept here is something called a daemon set. So daemon set is basically a interesting way of really you saying that if I have multiple nodes, then for on each and every node, I want to make sure a specific pod is always scheduled on each and every node. So this is typically use case for this is if I am really having, let's say, a cluster kind of an environment or any other storage system, or I want to really have a logging pod per node, then I will basically configure daemon set. So the way it works is whenever a new node is being added in the cluster, a daemon set defined pod will also get scheduled on each and every node. So that is the idea of daemon set. Any questions, guys, on daemon set or anything else so far? Okay, so let me go ahead and talk about the next two concepts which are relatively simple to understand. See, so far when I'm really dealing with the deployment objects or pod, most of my pods are really long-running processes. Is what I will use pod for. For example, nginx server or my node servers or things like that. So that's basically the nature of pods and deployment object. But if I happen to have different workload, so if I'm really doing a batch processing where my requirement is I have certain tasks to be done, I need to really create pods to do certain tasks, which will take certain time. But when the task is done, then I don't want those pods to be running beyond that. So there is a notion of completing the job. So there is a notion of bad job, and then there is a notion of completing the job. So let's quickly introduce these two concepts, and then we'll demonstrate how does Kubernetes, you can use this thing in the Kubernetes. So what I have is a YAML file called job.yaml, and here the API version here, what I have is, so this is a new class of this object called batch/v1. So in the batch processing part of the API, this job object is defined. And here there is a notion, there are two interesting attributes called parallelism and completion. So if I have a requirement where I know how my workload is being processed, then I will define the things as like completion. So in this particular environment, what I have is I want to create 2 worker pod, and total worker pod I really want to have it 6. And this is an hypothetical environment. So here my pod is just doing nothing, but it is really firing a Perl command. It is basically creating value of pi, but up to 2000 decimal points. So even on a fast machine, this operation typically takes, I think, 50 to 100 seconds, which is an awfully long time. So if I wanted, so this thing is just to show that, for example, you might have a use case where based on your data coming, somebody need to really do an image processing of each of the data which has come. So from your overnight data collection, you figure out how many images you need to process, and you allow, let's say, 20 parallel processing of the images is allowed, and you have 1,000 images. Then you might really say that completion is 1,000, parallel is 20, and then there is some kind of a pod which will be really running some kind of a server which will pull the image from some common repository and things like that. But once the image has been processed, then that pod job is done. So then you will have a second pod picking and processing the second image. So that is the notion of a job, and then that is the notion of completion of the job. So what I will do is I'll fire. I have this particular YAML file in my environment, so let me fire that, and then let's take a look. Okay, so kubectl get pods. Okay, my deployment is still running. So kubectl delete minus this. So this things get deleted. Okay, so I'll do kubectl apply minus f job.yaml. Okay, so here if I were to say kubectl get job, so I see there is a new job has been created, but right now it has like 0 completion. So total work item for this job is 6, but so far nothing has been completed. So now let's see what is really happening here. So if I were to look into the describe job slash pi, I get to see that it has created these pods. So it was creating 2 pods at a time. So it has right now so far created 4 pods. 2 is running, and if you see, like 2 has already succeeded or completed, and 0 has failed. Okay. So now if I were to go and look into this job, I'm going to be seeing, okay, by this time now 4 got completed. And after some time, you'll see all 6 got completed, 5 got completed, and 6 got completed. So once I say 6 got completed, then if I were to go and look into get pods, I see this interesting state for these 6 pods. They were saying like one for each of the pod, I was supposed to be requiring 1 container, but because the job of this pod is completely over, so there's no point in me running the container in those pods anymore. So that is the reason I'm having a state here called ready is 0 when required was 1, but I don't see it as a failure. See, typically what happens is if you are seeing 0, 1, then you'll assume that's a failure, but the status in that case is going to be some back off or error or some back off or something like that. But here my status is my pods has completed the job what they were supposed to be doing. And then why does the Kubernetes keep these kind of pods around? So that if required, you can just basically get some logs out of those pods. So I might say that now, what is the value of this? So this thing is basically 2000 digit value computation of pi. So in the log, the container which was running in the pod essentially has logged these things in the log. So I can go and really get this particular object or this particular information from that particular log of that particular pod. So guys, this is the basic concept of using Kubernetes job object for batch processing. You do not want to use the job for your normal long running server processing, but this is a very handy controller which is built again on top of pods called batch jobs. Any questions here on this so far, guys? Okay. So then I have something very similar here, similar to the jobs is something called cron jobs. See, typically if you have some scheduled job what you want to really fire at a specific time, then there are two ways you can handle it. You might have some scheduler which is outside the Kubernetes, or Kubernetes decided to provide the cron kind of a controller within the Kubernetes itself. So you can really specify the schedule of the job what you want to really create in the cron job itself. So let's look into the cron job specification. So if you see the cron job specification, again API is right now in like v1 beta 1. So job is only v1, not the beta 1 anymore, but the cron job object is still v1 beta 1, part of the batch API version. Type of object is cron job, and name here is there. So here is essentially this part is nothing but job schedule. So this thing is identical to the specification of a job, and the job specification was again having a specification which was in term having a content, basically pod specification. And so in the pod you had a specification which had container. So this is nothing but a specification of a job here. So here all I'm saying is once every minute please schedule this particular job. And what does the job do? This job is essentially logging in that particular busybox container the date and some message. And then because this is not a long running command what I'm really firing there, so once this particular command is fired, the container will say my job is done. So this is not a long running server process which is waiting or listening to a socket and things like that. This particular job is very simple job saying print the date, print the message, then my job is done. So what I'll do here is I'll really run this particular cron job here. So kubectl apply -f cron job, this one. So this particular job got created. Now I can really say that get even jobs or get cron job. So right now it is active. Schedule was just 5 seconds back. So because I was the specification here was every minute it was creating new job. So after 1 minute got elapsed, it created a job called hello so and so. And if I were to look into this one like get pods, so you will see that a new pod hello so and so got created 30 seconds back, and by now the status of that particular pod is again completed. And now if I were to go and really look into the logs of that particular pod, then I will be expected to see the date and that message. So I see the date when this thing was done, and then I have this message. Okay guys, so that's how you can really create the scheduled jobs using cron job. You can really create that, and you can really use the same Kubernetes itself for scheduled jobs. You don't need to have separate scheduler, separate outside third-party component, because these things are nothing but controllers. So Kubernetes has decided to give these controllers just within the Kubernetes ecosystem itself. Okay, so these are the basic concept on the controllers what I wanted to cover today. So just to recap, what we have done is we started with the deployment. what we could do, scale up and down, and as well as the rollback or upgrade. Then we looked into basically uh, batch jobs and cron jobs. And then in between, I just explained you the stateful and daemon set. So these are 5 6 different type of controllers built on top of the pod. Okay, so I'll come to the last topic for today, which is basically something called probes. So concept here is see, Kubernetes claims that it has inbuilt capacity of self-healing. See, so far what we have been seeing is we have been seeing that how does Kubernetes figures out any kind of failure at the objects it has created, which could be pod or replica set or node failures and things like that. And it does that by really going and monitoring the objects what it has created. So that is fine, but you might ask the question is what about container itself? Because container is something what Kubernetes ecosystem has not created directly. So if a container fails, but as long as pod is running, then Kubernetes will not be able to figure out that container has failed. So in that case, I will begin to really see some failures which what Kubernetes can't really handle directly. So to solve these problem, Kubernetes has basically introduced this concept of probes as an health check device. So there are three type of probes. So let's look into the first one is most interesting and most important. Remaining two probably are a bit more esoteric. So even if you don't get those things right, it doesn't really matter too much. So let's focus on liveness probe. So liveness probe, what does it really do? I'll show you a YAML file in few minutes here. So high level concept is when you are defining a container, you will define the probe, and then you'll also mention that how often this probe should be called. So for example, a probe might be really saying that I will make an HTTP GET request, which is a non-destructive request every 10 seconds. And if the request doesn't go through, then I will treat that as a failure. And in such a case, the Kubernetes should basically assume something really went wrong with the container and should try to restart the container. So that is a high level idea of the liveness probe. So let's look into the remaining two type of probes, at least from conceptual point of view. So readiness probe is something, a concept probably we will be able to better understand once we look into the networking, but let's introduce this concept high level anyway here. See, once a pod is up and running, it begin to listen, and once it becomes ready, then the something called services begin to send the incoming request to this particular pod or to a specific container. So, but if you say, guys, there is a delay between a container getting ready versus it is ready to accept the request. For example, until I have recovered my database in the event of a failure, or until I have done certain kind of checks, or it takes me usually few minutes before a container is ready to accept the request. Because once you have accepted the request, if now you are going to take basically a few minutes time, then the client will begin to see the failures. So you don't want that to happen. Then you say for this particular pod, don't even publish that I am ready. So that's where you'll use the readiness probe. Startup probe, I'll say, why don't you skip that whole concept right now? Let's understand the first concept, and then you can look into startup probe, because I don't see startup probe to be very, very common scenario most of the time. Okay, so in the probe, what can I really do in the probes? So there are three type of actions what Kubernetes allows you to really mention, specify in the probes. First is a very simple HTTP GET request. So you can say that on this container, this is my HTTP GET request, and if that GET request goes through, that means the server is up and running. Second is you say, no, it's I don't want to rely just on the HTTP request, because I am not really doing an HTTP server in the container, but I am really working on a specific TCP port. So then in those cases, you can define the TCP request, which I believe should not be very common for most of the REST-based API servers, what people are using these days, but that facility is available. And third is you say, I don't want to even do the networking. I just want to fire some specific shell command using exec bash kind of an environment. And so there should be something called custom command. So probe can really have any of these three type of actions. So what I'll do is I'll demonstrate the props what we have coded here. Okay, so I'll keep it very, very simple. So my liveness probe is, this is how you are going to be really configuring the liveness probes. So everything else is what you have seen so far. Deployment, it has a replica, selector, label, and containers. So this was my original deployment .yaml file. So what I've added is I've added the liveness probe, but be careful that liveness probe is an attribute of the container. Liveness probe is not an attribute of the pod directly. It is not an attribute of the deployment object either. So liveness probe is really an attribute of the container. So if I add multiple containers, then I can have different probes for each of the containers. So what my liveness probe is saying that this probe is of the type HTTP GET, path is so and so on so and so port. So initial delay second means wait for 15 seconds before you are going to initiate probing the liveness for this particular container. And then probe is called every 5 seconds is the interval between subsequent the probe calls. And then timeout for the probe is 1 second. So within 1 second, if you don't get response, then assume that particular container is dead. So these are the three attributes by which you can control how the probe should be really used. And this we have mentioned what type of command you want to use in that probe, and what type of probe is this. Okay, so what I'll do is basically I'll apply the liveness probe here. So it has created in this deployment object, so kubectl get, it's up and running. So liveness probe is kind of doing its job. So here basically if you see in this container, the liveness attribute of container is enabled, and these are the parameters there. So liveness probe, HTTP GET is the command, this is the port number, and so are the delays, timeout period, and things like that. So if one of the probes succeeds, I'll treat it success, but I need to see 3 failures before I really declare that this particular container is dead. So sometime I might be getting 1 failure, which is a transient failure. So this is basically by making sure that failures count is more than 1, I'll make sure that I'm protecting this container against the transient failure. Okay, so what I have here is basically I have one more YAML file where what I've done is I want to have a probe which fails. So you know that this particular container is listening on port 8080, but I have configured a probe which is trying to use the port 8090, which is of course going to fail. So now let's see what happens if I were to apply such a YAML file. So my deployment object get created. There is no failure at the deployment object level. Okay. So pods are there basically still up and running. But if I were to look into these things, get pods. So here basically you will see this particular pod is also up and running. But what is happening is my container is dying here. So in that case, how do I figure that out? So then I should be doing something called a log of this particular pod. No, I don't. This thing is running on this part. Okay, so let's describe this particular pod here. Describe pod. See this. The liveness probe on that has failed. So I see a warning here, and which says my pod is unhealthy, and because it has detected this thing was unhealthy, because this connection was refused. So now Kubernetes has taken an action of killing this particular container. But after killing the container, it doesn't really fail the pod. It just really restart the container. So it will be keep doing this thing over and over for many number of times based on what was the number of times what you have mentioned, or which was the default in the Kubernetes. So it will keep trying for some time before it gives up. So this is basically what I really have today for the HTTP probe for the liveness, and there are different examples I have for the command and TCP, but you can find those examples in the Kubernetes documents also. So basically, this is basically what I was intended to create today. I'll skip the readiness probe because concept is very similar to liveness probe. Okay. So any questions, guys, you might have for me? Let me see if I have covered everything here, what I wanted to cover today. Okay. So I think that's all, guys. So I think today's session was hopefully most interesting to cover the use cases of Kubernetes, which is continuous deployment, scale up, scale down, and then the health check. So with today's background, I think you can potentially get started creating your own deployment YAML files, begin to put the probes there, begin to scale things up and down, and then see whether things begin to work for you or you have certain challenges there. Okay, so as usual, looking for your support. If you think there is anything what you are doing in the Kubernetes where we can help as a company, feel free to reach out to me. I'm asking somebody in my sales team to also reach out to you to really have some personal rapport to see anything where we can help you guys. Okay, any other question? So Siva is asking what will be the content for the next session. So I think next session I'm planning to cover Shiva the services is something what I want to cover next time, where we'll talk a little bit about networking. We'll look into the different type of services to really expose each of the pod. So there are three type of services we are going to talk about: basically cluster IP, load balancer, and the node IP. So we'll be looking into those aspects in the next session next week. I will try to repeat the same session on the coming Friday morning, depending on the response. Okay, guys, anything else I can do for you? Ingress, let me try to cover. I have not really done much of the ingress, but I'll try to cover the ingress also. I think let me do some work on that. Okay, guys, then thanks for joining me, and hope to interact with you guys next week. Bye. Have a good day or good night.